So, hi everyone. I'm the group leader for this week, for Group 7. And this week experiment is experiment 6. And the experiment is Bourdon tube pressure gauge open ended experiment. And our group consists of 4 people, which is Anish Shazwani, Muhammad Tariq, Zulkifli, which is Datuk Z, basically it's me, and Ko Yong Kan. So, let's proceed.
Assalamualaikum and hello everyone. My name is Anisha Zwani and now I will explain about the abstract. The aim of the experiment is to perform pressure calibration on a Bourdon tube pressure gauge using a dead weight tester. The experiment is done by inserting piston into the cylinder and air bubbles inside is removed by rotating or pushing the piston. When piston is inserted in the cylinder, the pressure gauge deflects as the first reading. Then, load weights are added slowly until total mass reaches 6 kg. Procedure are repeated for increasing and decreasing weight load for 2 times. The experiment is conducted successfully as true pressure is almost the same as the pressure recorded. The input reading is the weight on the piston produce a known pressure in the vessel equal to the weight divided by the piston area, while for the output reading can be obtained from the pressure gauge.
Hi everyone, I'm Koyong Khan and I will continue to present the objectives of this experiment. So for this experiment, there's 2 objectives. First one is to calibrate a Bourdon tube pressure gauge using big wax. So the second one is to compare the experimental results with the theoretical value.
Now I will explain about the introduction. Bourdon tube is one of the equipment to measure pressure. Before any measurement system or equipment to be used, it is compulsory to calibrate the equipment so that the equipment can be just as accurate as the working standard. To calibrate a measurement system, you have to compare its output with the standard known input. In this experiment, we have to calibrate the Bourdon tube pressure gauge by mounting the transducer in a closed vessel with a piston at one end called a dead weight tester. The weight testers provided were in various standard weights. You need to study the Bourdon tube principles and any related information as much as possible prior to the experiment. Students are expected to independently perform this task.
So now I will continue with the theory. So for this experiment, the pressure intensity at any point in static or moving fluid can be measured using various types of pressure measuring instruments. One of these devices is the Bourdon tube pressure gauge. Bourdon tube pressure gauges are most widely used nowadays because of their reliability, compactness, low cost, and ease of use. This gauge is widely used for steam and compressed gases. The pressure indicated is the difference between the system pressure and the external pressure and is usually referred to the gauge pressure. So you can see there's a three figure in this slide. The first one is a Bourdon gauge consists of a thin wall tube that is bent into a quarter circular arc as shown in the figure below. So you can see in the figure, the Bourdon gauge consists of a Bourdon tube that's circular arc size and there's a head spring inside the Bourdon gauge. So the second figure, when pressure is applied to the tube, it tends to strengthen out. So when the pressure increase, the tube will strengthen out and expand to outward. So for the third image, you can see the diffraction of the image. The diffraction of the end of the tube is communicated through a system of levels to a recording pointer. So when the tube expands out, we will move the calibration link and the rod and gear will start to rotate. And the rod and gear will rotate the pointer too and show us the calibration. So the Bourdon tube tends to become weaker if the Bourdon gauge is used frequently. Hence, calibration is necessary for Bourdon gauge to provide accurate pressure measurement. The Bourdon tube pressure gauge is loaded with known pressures using a deep wet tester. This deep wet tester uses a simple piston and cylinder arrangement to provide a source of pressurized liquid which is transmitted to the gauge. Since the true pressure of the liquid can be easily calculated, The value can be compared directly to the reading on the gauge over the complete zero range. So it's like show us how to calculate the theoretical pressure. It's very easy. Since a piston of known area is denoted by known mass, therefore the actual pressure in the cylinder is pressure equal to force over area, and the force is equal to mass times the gravitational force. Since the theoretical pressure need to in the value of in the unit of kilopascal is equal to the kilonewton over meter cube. So we need to divide by 1000, and the equation will be pressure equal to mg over area times 10 power negative 3. So that's all for the theory.
Hello guys, my name is Muhammad Tariq and I'm going to show you the methodology for the experiment. Okay, for the left side we have the picture of apparatus and we also have Bourdon tube pressure gauge, piston and some dead weights. And then for the right side we have some parameters information about piston area, pelanggaran platform and also calibration constant for total mass each unit. Next, so this is the methodology. First thing first, a cylinder and a connecting transparent tube are filled with oil. Then the next step, piston is inserted to cylinder. Third, ensure the bubble are removed. Fourth, write down the first reading. Fifth, weights are loaded slowly. Sixth, then wrote the second reading. Seventh, steps 5 to 6 are repeated until total weight reaches 6 kilos. 8. Unloaded the weight by removing one weight. 9. Wrote down the reading for removing each weight. 10. Step 8 to 9 are repeated until the weight removed from piston. 11th, step 2 to 10 are repeated until 2 times to get average reading.
Okay, so I will talk about the result and discussion. So let's go to the result first. So the result from this experiment, we record the mass added, and the mass added for each time we add the weight is 0.5, the increment. And then the total mass we record total mass. Also, we do record the pressure exerted by total mass, and the unit is in kilopascal. And then we do record the loading for 3 times, and the experiment is conducted for 3 times, and then we get the average. And we do the exact same thing for the unloading. We repeat the experiment for 3 times, and we get the average. And the unit recorded is in kilopascal. After that, we find the loading and unloading percentage error. That's all. Thank you. Let's go to the discussion now. So the first question, the percentage of relative error for the theoretical and measured pressure gauge. So the method of calculation. So the mass of piston is already given, which is 1 kilo, and also the cross-sectional area of the piston is already given, 3.1731 times 10 power of negative 4 per meter cube. So we calculate through pressure exerted by the piston by using the formula mass times 9.81 times negative 10 power of negative 3 divided by the area. Then we got 30.9. Then we find the true pressure exerted by total mass. Then we got 46.4 kilonewton per meter cube. And then we find the average reading calibrated pressure, and then when we calculate that, we do change the unit. Then we got 30.3 kilonewton per meter cube. Last but not least, we find the percentage error for loading and unloading, and both using the formula measured value minus actual value divided by actual value times 100%. For loading, we got 34.7%. For unloading, we got 13.0%. That's all. Thank you. The second question, they ask us the source of error and method to minimize the error. So source of error, the first one, when weight is added, the dead weight pressure gauge calibrator responds slowly to change in pressure and hysteresis, which may cause friction to occur. So the method to minimize this error, we rotate the piston in order to remove the air bubble inside the cylinder tube and to reduce friction so that more accurate pressure reading can be obtained. Second, when inserting the piston into the cylinder, there still might be air bubbles that not totally been removed from the cylinder and hose. So what we need to do, we we need to make sure to remove air bubbles from the cylinder and the hose. The hose is the transparent tube. So the apparatus is sensitive to shocks and vibration. While we are conducting this experiment, once we accidentally move the table, it will influence the reading to defect. So the members should be more careful while loading or unloading the weights. Repeat by taking the reading for 3 times to get a more accurate result. Then, last but not least, the parallax error also occurred when carrying this experiment. The position of eyes are not perpendicular to the scale of the Bourdon tube pressure gauge. So, in order to overcome this error, we should take several readings and calculate the average. Other than that, the reading could be taken by several people. And then the third question, they're asking repeatability and accuracy of this equipment. The first one, the repeatability in the world of Bourdon tube pressure gauge mean essentially the same thing. It means within the realm of floor meters or other measurement devices. Second, it is measure of how consistently the pressure gauge is accurately repeating the same measurement if all conditions remain the same. Last but not least, for example, if exposed to the same pressure on two separate occasions, the gauge will show the same PSI if all other ambient factors, which is the pressure and temperature, remain the same. And then accuracy of this equipment is similar to the repeatability. It's a little more nuanced, yet equally and independently important in determining the quality of a Bourdon tube pressure gauge. Second, accuracy is a measure of how effectively a pressure gauge is in repeating the upscale reading on the downscale cycle if all conditions remain the same. Last but not least, for example, while a pressure gauge may read correctly at zero midpoint and full scale during the pressure up cycle, it may read too high at the midpoint check during the pressure down cycle while still correctly returning to zero. That's all. Thank you.
Last but not least is the conclusion. Now I will explain about it. Based on the experiment, we can conclude that Bourdon gauge is one of the suitable instruments to measure the pressure, but the readings were not accurate as the actual value. The readings which were recorded from the experiment are consistent and closer to the actual value. The errors cannot be corrected but can be avoided to minimum.
So that's all from us. Thank you. So we meet you guys next time on experiment 7. That's all from our group 7. Thank you for listening and watching the video throughout. Thank you. Bye bye.